Okay, today we're going to be talking about inverse and determinants. We're going to start with determinants of a matrix, and we're going to move into how do we find the inverse of a matrix. Both really important topics. So let's start with deciding, okay, what are we going to accomplish today? Today we're going to accomplish finding the determinant of a matrix, finding the inverse of a matrix. We're not going to, in this lesson yet, get into how to use matrices to solve a system of equations. We will in the next video get into that. All right, so right now we're going to just talk about matrix operations and how do we find the determinant of different things. So we're going to first start with this idea of a determinant. So right here we have that the determinant of a matrix equals, and if you notice it kind of goes from these matrix braces to absolute value symbols, which you might realize kind of does look like absolute value symbol. And we'll come back to what over here in just a little bit. But what we're going to be doing is you're going to be taking A times D and subtracting it from B times C. Okay? So what you actually do is you end up taking the down diagonal minus the up diagonal multiplied by each other. So let's see that in practice here. We're going to start with finding the determinant of this matrix. Now if you remember, I told you we're going to take the down diagonal. Here's my down diagonal, 3, 8. All right, so I'm going to take that and I'm going to say 3 times 8. And I'm going to subtract my up diagonal. So let's look now at my up diagonal, which would be right here. Okay, and that's going to be -1 times 5. Well, 3 times 8 is 24. -1 times 5 is a -5. 24 minus a -5 is the same thing as 24 plus 5. Our answer is 29. So the determinant of any matrix is a single number. It's a single value. So your determinant is just an individual value. So the answer here is the determinant of this matrix. The answer is 29. Now, we could go to a bigger matrix, a 3 by 3 matrix. So here's our 3 by 3 matrix, and what you do to find an inverse or a determinant, actually this is how you do an inverse. Finding a determinant is even more interesting. Let's say we have a 3 by 3. I'm just going to come up with one. 3, 2, 1, 1, 2, 3, 5. I'm making up numbers now. 7, 4. What you do is first you're going to take this top value, the 3, and you're going to multiply that by the determinant of 2, 3, 7, 4. Well, how did I get 2, 3, 7, 4? What I did there is I actually got rid of the row the column and the row that 3 was in, and I'm going to multiply it by the matrix there. Then what I'm going to do is I'm going to take and I'm going to do the same thing now. I'm going to get rid of this for a minute. I'm going to do the same thing for the 1. That's my 1. All right. All right. Now we're going to get rid of the matrix or the rows that this is in. This is a little bit reminds me of how we solve a Sudoku puzzle. And we're going to multiply by the determinant here of 2, 1, 7, 4. And then I don't have space here, so I'm going to go in the bottom. I'm going to multiply by the 5, and it's now going to be the determinant of 2, 1, 2, 3. Kind of involved. And I know a lot of you are thinking, there's got to be an easier way. This seems really involved. It seems like I can make a lot of mistakes. You could, and you may. There is a better way. The better way is using your graphing calculator. All right, we learned, hopefully you watched the video on how to enter in matrices into your graphing calculator. So I'm going to assume that yes, you already know how to put a matrix into a graphing calculator. And we'll be reminding you here, and we'll be showing you here how to do it. But I want to let you know too that in the math, one of the first things you have here in the math section is this determinant, and that's finding the determinant of a matrix. Okay? So let's look at a problem. Let's go here and say, okay, we want to find the determinant of this matrix. Our first step will be to go into my graphing calculator. So there's my simulated graphing calculator. In my graphing calculator, I need to first edit. I need to put in my matrix. So I went and I right arrowed to edit. I'm going to hit enter. And it's in matrix A. This is a 3 by 3 matrix that we're dealing with. And if you remember, our matrix was 4, -2, 3, and then the second row was 5, 0, 1. The third row, was 9, 0, 1. So now we have our matrix entered. I'm going to quit out of there. So I have my matrix entered. That's what I was hoping for. So now the big keys that you need to know is you need to go back to our matrix. Oh, and I went to the wrong one, sorry. Back to our matrix. Now instead of going over 2 to edit, I'm just going over 1 to determinant. So I'm just highlighting determinant and I'm hitting enter there. Highlighted determinant and I hit enter. Now I need to tell the calculator determinant of what? I need to go back second matrix, so second X inverse. And I want to say of matrix A. I put in my matrix into matrix A, so I just have that name highlighted. The name highlighted, I put it in there. Now you can go ahead and put the parentheses here. You do not have to have those parentheses. So this operation is saying find the determinant of matrix A. Look, it did it for me. It found that the matrix A determinant is a -8. So now, really just by doing that, I know that my answer here is -8. It kind of saved me a lot of time of what it would take normally to find a different matrix and to kind of use my kind of longhand. If you want to know the longhand way, the way to do it by hand instead of using a graphing calculator, feel free to look in the book. It is there. Now we're going to talk about inverse. Well, inverse, what we do for an inverse is we say, get the determinant of that matrix. Then you have 1 divided by your determinant here is multiplied by, and if you notice, these 2 were switched and these 2 were made negative. So you take 1 divided by 1 over the determinant, or the inverse of the determinant, and you multiply it by kind of the original matrix but kind of switched around. So let's look at that here. All right, here's our problem. We had, and I gotta look here what our problem is. We had 3, 5, -1, and 8. And we were asked, find the inverse of this. A lot of times this is the way they say find the inverse, is they'll use that little -1. Okay, well, I first have to find the determinant. So I'm first going to find the determinant. If you remember, those little absolute value marks is how we say we're finding the determinant. That equals, we go down diagonal, 3 times 8 minus up diagonal, -1 times 5. All right, so that was the 24 minus a -5, and we found that was 29. Okay, so we have 1 over 29. Now we're going to multiply that like a scalar multiplication by the switched around matrix. So I'm going to switch around my diagonal, so my 8 and 3 switch places. My other diagonal doesn't switch places, but if it's a positive, it goes to a negative. If it's a negative, it goes to a positive. So now I have a scalar multiplication. So this one actually looks like this. 8 29ths, and we go -5 29ths, 1 29th. It does look this crazy at times, and 3 29ths. That is my answer. That is my inverse. I kind of came up with a matrix to begin with it just off the top of my head, and sometimes those inverses don't look pretty. Most of the times they do look nice and they come out with nice, bigger, more even numbers, but sometimes this is what we get. So that is the answer to what is the inverse. I have a feeling in your head you're saying there has to be an easier way. And the good news that there is, and if you might even guess, it has to do with our calculator. So I'm going to clear this. Now, if you remember, and I'm going to jump back here, we want to find the inverse of this matrix. So we need to put that matrix into our calculator. It doesn't matter where I put it, A, B, C, D, it doesn't really matter. I'm going to go ahead and put it into A. So I'm going to go second matrix. I'm going to go over to edit. Into my A matrix, I'm going to put a new 3 by 3 matrix. And I'm going to just replace the numbers that I have. So my new numbers of the matrix I was just looking at was 0, 1, 2. So we don't have to clear our matrix every time we do it. The next number was -2, and then we had 3, and then we had 0. And then finally it was 4, 4, and -2. All right, so that's our matrix. Now I can quit out of that. I hit second mode or second quit to quit out. Now I need to find the inverse of that matrix. So I'm going to go second matrix. I need to name it. I need to say A inverse. So I'm just going to click on the A, and you can see that what appears on the screen is that A. Now what I want is I want that inverse. The inverse key is just right here. It's just this inverse key. That's telling my calculator, hey, please find the inverse of matrix A. I'm going to hit enter, and look, we get lots of decimals. In other words, it's just kind of as icky as the one we did in class. Boy, it would be nicer if we had fractions. Well, the good news, there's an easy way to do that. You just hit the key math, enter, enter, math, and then enter twice. We'll put that matrix into fractions. Oh, that's not so bad. So now we have those nice little fractions there, 3 over 22, -5 over 22, 3 over 22, 1 over 11, 2 over 11, 1 over 11, and then 5 over 11, -1 over 11, -1 over 22. Our answer though, and boy, that's a lot easier than calculating it by hand. Okay, so I'm not going to recopy that, but we remember and we have that answer. We could copy it down on the homework. So your things, practice problems that I'd like you to give a try. I want you to find the values of each determinant and find the value or the inverse of the different matrices. Now, every once in a while, an inverse or a determinant does not exist. You can only take the determinant of a square matrix, meaning the rows and the columns have to be the same value, 3 by 3, 4 by 4, 2 by 2. You cannot take the determinant of a 3 by 8 matrix. That doesn't work. It has to be square. Same thing for inverse. It has to be square. I hope you enjoyed this.